Bismillah ar-Rahman ar-Rahim. In previous meetings we talked about the ordinary annuity and how we amortize loans. Okay? Today I'm going to talk about three things. First about the annuity due. Okay? Annuity due. And the second we'll talk about, so this is annuity due. The second we will talk about the perpetuity. And the third we will talk about the complex cash flow. Complex cash flow. So we will talk about the three main things in this chapter. Okay, let's start by annuity dues or annuity due. As I said before in the first meeting in this chapter, I talk about the two types of annuity. The first one is ordinary and the second is the annuity due. Just to remind you with the difference between them, and if we have this cash flow stream, okay, so according to the annuity due, the cash is coming all discounted at the beginning of the period. However, this is for the due. However, for the ordinary annuity, at the end of the period. So, how this policy influence on the equation? Just multiply the equation by 1 plus I. 1 plus I. Okay? So just multiply this by 1 plus I. For instance, if you have cash flow stream and it is annuity due, and I ask you to calculate the future value, then the future value is equal the present value 1 plus I raised to the power n. In addition to this, just time the results by 1 plus I. Okay? And for the future value annuity, if we talk about future value annuity, okay, so present value is time by 1 plus I, okay, raised to the power n. This is the this is the future value for general. Now we want to amend this equation according to the annuity and according to the present value. Go back to the examples and the checkpoints and just time the results by 1 plus I. If you time the result by 1 plus I, you will get the annuity due. Okay? So if you look at here, the future value for annuity, this is for future value, is the payment 1 plus I raised to the power n minus 1 divided by I time by 1 plus I. Okay? So this is the difference between the annuity due and the ordinary annuity. In the ordinary annuity, we don't have this. But in the ordinary due, we have to multiply this by 1 plus I. What is the reason behind this? Why we multiply by 1 plus I? Look at this stream. Consider this case here. This is starting by 0. It's 1, 2, 3 till alpha. For the ordinary annuity, as we said, it is starting from the end of the period. So we time 1 plus I raised to the power n. But for the due, we have this period of time. So we have to multiply the equation by 1 plus I because we have this space. We have 1 year left for the future value and 1 year left for the present value. This is why we multiply the whole equation by 1 plus I, because we have one single period is not considered in the ordinary view, in the ordinary annuity, but we have to consider this when we calculate this on the annuity due. This is why we calculate based on the time 1 plus I. And in the same thing for the present value, the payments, the main payment 1 minus 1 plus I raised to the power n divided by I. Then after this, time this by 1 plus I. Okay? So this is the idea, or this is the difference between the annuity due and the ordinary annuity. Go back to the example, or revisit the example. Okay, look back to the example and see where we calculated the future value of 10-year ordinary annuity over $3,000, yielding 5% to be $37,734. You have to apply this equation to calculate the annuity due. So the payments time 1 plus I minus 1 divided by I. Okay, raised to the power n. After this, 1 plus I. Try to do the calculation by yourself to see the difference between this one and the previous one. Apply this equation, okay? Apply this equation. Okay. So what is the payment? 3,000. 1 plus I. I is, sorry, 5% or 0.5 raised to the power 10 minus 1 divided by I is 0.5, and then time 1 plus 0.5. How much? 39,620. Which you think is much better for the investors? Annuity due or the or ordinary? Okay, go back to the ordinary or calculate this based on the ordinary and see the results. The ordinary due? Yeah, because you have more cash flows, or you get benefit more in this. But it depends on you as investors when you get the cash flow or when you deposit the cash flow. Okay? And you can do it in Excel. Okay? Go to the Excel. Okay, in Excel we have payments, we have I, or we have N, and we want to calculate the future value. Okay, so what is the payment? 3,000. Okay, let's see. Okay, I 5%. N is 10. Now we want to calculate the future value. So the future value is equal like this, and write the future value. The future value, the rate is 5%. Okay. Then the payment is 3,000. Then the present value is Sorry? We want to the payments. Okay, we have. Okay, we need the payments. The payment is 3,000. And the type here is important. If you put 0, the payments how many times? Just a minute. This. Oh. Let's go back. And 10. 3000. Oh. Okay. So the future value the rate is 5%. The number of period is 10. The payment 3,000. And the type is here. If you put 0 and if you put 1 is different. So see the difference now. Format cell. Now, go back to the equation here. If you observe in type, we put 1. It is due. And if you read this, if you put 0, it is ordinary. See the difference now. So it is 37,000. Okay? So this is the difference between the annuity due and the ordinary. Okay? And the difference is worth. We will see. We will calculate this based on the annuity and one based on the ordinary due, and to find the difference between them. We'll recalculate the equation by using the annuity due, and we'll see the difference. The number of period is this, then the payment is this one, and instead of 0 we will put 1. So it is. Now what is the difference between them? Is 1,886. What do you think this difference? Why this difference? From where this difference is coming?
There's much more time for this one. So that's why it's higher.
It means you have more cash flow. It means more 1 year cash flow, or the difference is in calculating the interest. Sorry?
Did you any more period? So
more period, it means more cash flows or more interest. Decide which is the right. Sorry?
More cash flow.
It means we add a new year or a new cash flow or a new interest. Okay? Because interest is accumulated, okay, and we add 1 more year interest, not cash flow, because the cash flow is fixed. But if you look at here, for instance, just for 3 years, if we have 1, 2, 3, look at the difference. And here starting by 0, this is 0, this is 1, this is the beginning of the year, and this is the end of the year. And here is the beginning of the year, and this is the end, and this is the same. So if the cash flow is coming from here, you invest this cash flow for 2 years. So you only invest for this 2 years. And 2 years, you get benefit for this, in this example, 5%. But if you're starting from here, you get benefit for 3 years. If you start from here, 1, 2, 3. But this one is, so we have 1, 2, 3. The first payment, you get benefit 2 years, okay? The second, 1 year. The third, 0.
Yes.
Look at the annuity due. The same example here, 1, 2, 3. If you're starting from here, so you get benefit 3 years. Then this one, 2 years, and this one, 1 year. Okay? So because you have more space to invest your money, so this is, you maximize your cash flow. You maximize your cash flow because you have more space in calculating the interest rate or the benefit of interest rate. Okay? Any question? So try to recall the questions and do the same. Recall checkpoint 6.2, check yourself problem where we computed the present value of 10-year ordinary annuity of $10,000 at 10% discount rate to be equal to 61,446. So this is on the present value. So this, you will apply this equation to calculate the present value. So the present value is this annuity. Compute the present value of 10-year ordinary annuity. Yes. Okay. So it is the payments 1 minus 1 divided 1 plus I raised to the power n. Okay. Divided by I. But don't forget to multiply this by 1 plus I. Sorry? No, I'm talking about this is annuity due. The question is annuity dues. Okay. Recall checkpoint, check yourself problem where we computed present value of ordinary due of to present value to be equal this. So we want to calculate the annuity due, but it's being calculated based on the ordinary annuity. It's being calculated. So now just revisit this example or this equation and apply the annuity due. So look at what will be the present value of $10,000 is received at the beginning of each year. So annuity due. For example, the cash flows were annuity due. So in this case, the annuity due, and try to do the calculations here. The present value, the payments is 10,000. 1 minus 1, 1 plus I. I is 10%. Yes, 0.10 raised to the power 10 divided by 0.10. And here 1 plus 0.10. Okay, so do the calculations. And let's see our Excel. Thank you for Excel to do all this job. And my student in financial analysis, they are enjoying in Excel. Yes, too much. Okay. So the payment is 10,000. and I is 10%, and N is 10. Now we want to calculate the present value. So the present value go to the is equal present value, or go to the rates is 10%. The number of periods is 10. The payments 10,000, and now this type 0 or 1. So 1. Okay. Just from the discount rate. Okay? Is it clear this? Yes. Make your mind up. Try to think. Okay? It means, in other words, we save 1 year from the discounted. We are not discounted 1 year. 1,000 is 1,000, but in the ordinary, this is discounted. The first payment is discounted. Again, this is why the payments or the present value in the ordinary, in the annuity due is greater than the present value in the ordinary. Okay. Perpetuities. So this is the second things that I will talk about what it means perpetuity. Okay? What it means perpetuity. In any language, in Indo, in Dutch.
It's like the annuity, but it has
No
no majority.
maturity. Okay. Can you give example of this? You are right.
What active revenue stream are you?
Yeah? Yes, waqf. Yeah. Waqf. For instance, in the Muslim countries, we have things known as al-waqf. Waqf. Okay. أرض وقف. أو ممكن it's not necessary to be waqf. Maybe some charity organizations, they invest.
Yes.
They invest their money, and they state this investment for unlimited period of time or forever. This is on forever. This business is on forever, like the charity organization. In the Muslim countries, we have known something in the al-waqf. In the Christians, they know the church. They have their investments, and these investment to fund the church activities. So this is known as the perpetuity. Corporations also issue the perpetuity bonds. The perpetuity bond is forever, is on forever. Is that you cannot sell this this security. So this security belong the institutions or belong the government for unlimited period of time. For perpetuity is important for the government, is important for the charity organizations, is important for some religious to secure the stream of cash flows for their activities. Okay. This is why it's called perpetuity, because unlimited. Okay, and you cannot liquidate this into cash. Another example here, the IUG, Islamic University of Gaza, they offer the investments or invest in something looks like the perpetuity, new buildings and new investment to fund the poor students. So the benefits of, or the cash flow, or the benefits of this investment is for perpetuity, and to fund the activities or the tuition fees of the poor students. So these examples of the of perpetuity, the IUG itself has no right to sell this, because this is for a particular objectives and for a particular issues. Okay. We have two types of perpetuity. We have level perpetuity and we have growth perpetuity. And very simple to calculate this is very, very, very simple. Perpetuity is an annuity that continues forever or has no maturity. For example, a dividend stream on a share of preferred stock. There are two basic types of perpetuity. Growing perpetuity. Okay? The growing perpetuity, it looks like this. For instance, after 5 years, this perpetuity is growing up every 5 years. And looks like this. Okay? So every particular period of time, it is growing up. For instance, again, if they have profits, if they make profits, they capitalize this profits, or they retain this profit and make the growth, do expansion, and looks like this. However, the level perpetuity looks like this, is fixed. The stream of cash flow is fixed, no change. In Gaza, we have many examples of perpetuity funds. مثلا بساتين ستريت، شوفوا شارع البساتين. هذا للوقف وهذا إلى ما لا نهاية. بياخذوا إيجار من المنتفعين لمصلحة وزارة الأوقاف. فكرة البربتويتي إذا هذا for alpha. الكاش flow is for alpha, so is unlimited. So the growing perpetuity is this business is grow up within 3 years, within 5 years, whatever. Level perpetuity, there is no growth, in which the payments are constant rate from period to period. How we calculate this? The present value is payment divided by I. The payment is the payment, the cash flow, and I is interest rate or the income rate or the mudaraba rate or whatever. Okay, any rate. I recommend you to read about Islamic financial transactions. Okay, this is important. أنا باخذ كورس هلا بالإسلاميك financial transactions أساس أسي So this is important because it's important to include the Islamic financial securities in financial management. Okay. 2 weeks ago, London issued the first Islamic sukuk in London, which it cost them $200 million, and they issue the Financial Islamic Index. This is two weeks ago. Okay, so how we calculate this, the present value of a level perpetuity. Take this example. What is the present value of 600 perpetuity at 7% discount rate? So the present value is payment divided by I. So payment 600 divided by 7. So it's cost 8,000. But if we have a growth rate, so payment is I minus J, and this is, remind you with the preferred stocks, how you calculate the value of preferred stocks in investments. So the present value of level perpetuity, what is the present value of a perpetuity of 500 paid annually discounted back to the present 8%, just divided 500 by 8%. Okay? So this is 500 by 8%. And this is the same. What is the present value of stream payments equal to 90,000 paid annually? So 90,000 divided by 9%. Okay? So this is the same. For a growing perpetuity, in growing perpetuity, the periodic cash flows grow at a constant rate. How we calculate this is the payment divided by I minus G, and be careful, I must be greater than G. Okay? So what is the present value of perpetuity stream of cash flows that pays $500 at the end of year 1, but grows at a rate of 4% per year indefinitely if the rate of interest used to discount the cash flow is 8%. So 500 divided by 8% minus 4%. Okay? So this is the answer. Okay? See, the answer is in here. Now, complex cash flow streams. Okay? This is the last thing in the complex cash flow streams, and then we will finish this chapter. Complex cash flow streams, unfortunately, the cash flow is generally not coming as regular payments. Okay? The cash flow is coming, the majority of cash flow is coming as irregular payments. Consider this case. Okay? So we have here $1,000, and okay, here we have 2,000, and then 1,000, 1,000, okay, and 2,000. So this is irregular cash flow. If we want to calculate the present value of this, we cannot apply the present value annuity or the future value annuity, because we have fortunately, and this is good for you in this chapter, because this chapter is for undergraduate students, and this is chapter very simple. But we have in the complex cash flows, we have some policies how we can amend this to be annuity or regular. For instance, see this. What we can do, okay, we can do like this: 1,000s, 1,000s. And we have 1,000 here and 1,000 here. It is the same. So this divided 2,000 is divided 1,000 and into 1,000. So here we have regular cash flow, and here we have cash flow is coming here and cash flow is coming at the end. So instead of using these techniques, we just, in two equations, we sort out this problem. Okay? Consider this case. One, two, three. We have 2,000s, 4,000s, 4,000s. Okay? So how we can solve this out if we want to calculate the present value? If you want to calculate the present value, this is 2,000 times 1 plus I raised to the power 1. And this one is 1 plus I raised to the power 2. And this is 1 plus I raised to the power 3. If we want to calculate the present value, and we have the sum of these. But other people, they may use different techniques. Okay? This is, you can calculate this 4,000s. This is looks like annuity, and you have this one, you calculate this one separately. So we may use two. Or this is one technique. You can use another technique. Okay, this 2,000s, 2,000s, 2,000s. Is it right? And we have here 2,000, 2,000s. We can sort this out by you calculating these cash flow as annuity and these as annuity. Okay? At the end of the day, using either this or this, you will end up with the same results. Okay? This is very simple. Let's go to the idea of the complex. So the cash flows stream in the business world may not always involve one type of cash flows. Regular. The cash flows may have a mixed pattern. Maybe after the second year you get cash outflow, not cash inflow. Okay, we take negative sign. For example, different cash flow amount mixed in with annuities. For example, figure 6.4 summarizes the cash flow for Marriott. You know what is Marriott? Hotel. Okay? Look at this. So in this example here, we have $500, then $200, then minus $400, and the rest is annuity. Okay? So what we can do, we start by here, $500 is discounted by, as we said here, 1 plus I raised to the power n, 1. Then this is raised to the power 2, and this is raised to the power 3. You finish this. Now, you discounted this by 1, 2, 3, 4, 5, 6, 7 years annuity. So you are using here annuity. Then after this, you discounted the payments. Okay? But in Excel, we don't need to struggle on using all of these techniques. Just in one click, you can do all the equations. Take this example here. Look at this example. What is the present value of cash flows of $500 at the end of years through 3 at the end of years through 3. So it means a cash flow of a negative 800 at the end of year 4. So we have 1, 2, 3. We get $500. Okay. Then in the year 4, we have 1, 2, 3. In the year 4, we get negative 800. So we have negative 800. And cash flows of 800 at the end of years 5 through 10. So 5, 6, 7, 8, 9, and 10. 500s, 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 and 500s. Sorry? Oh, 800. Okay, 8, 8. Okay, so what we can do this? So, first of all, we have this annuity. Okay. We discounted this based on the annuity. These payments, all of these payments as annuity, and you apply the payments time 1 minus 1, 1 plus I raised to the power n, so raised to the power 3, okay, divided by I. You apply this equation. Now, and you have the results in here. The second, 8, you discounted by 1 plus I raised to the power 4. And you get the results. This, it has a special treatment. Because it's coming after 4 years. So it has special treatments. How we can treat this? Okay, this is annuity. We discounted as annuity by applying the equation, this equation, payments, 1 minus 1 divided 1 plus I raised to the power 1, 2, 3, 4, 5, 6, 7. Sorry? Sorry, 1, 2, 3, 4, 5, 6, yes. Okay? 6 payments divided by I, and that's it. Then you get the results. When you get the results, this result you discount it in the year 5. So you have to discount it again. You discount this by divided 1 plus I raised to the power 1, 2, 3, 4, 5 raised to the power 5. And you have the results here. Just sum these amounts. Okay? You would see, as we did here, the first 3 years, then this one, then you do the payments, beginning of years for 5 years, end of year 4, and you try to do it by yourself and see the results. Okay? This is the complex cash flow. At the end, just to remind you the main key terms, we talk about the amortized loans, annuity, annuity due, annuity for future value, and annuity for present value. We differ between the growing perpetuity and level perpetuity, loan amortization schedule, ordinary annuity, and perpetuity. Okay? And this is the end of chapter 6. On Saturday, we will talk about chapter 7. So prepare yourself. Okay? I may ask Noor to do some calculations and to answer the questions. Okay? يعطيكم العافية.